Alright, welcome back. We're just going to practice using a Pythagoras theorem to solve for some shorter sides quickly again, but this time we're going to do some rounding, because obviously not every single right angle triangle is going to come out to have whole numbers for each side. So let's solve these first. So again, if we look at A, we know that our Pythagoras theorem is c squared equals a squared plus b squared. Now, because we've been given c, we've been given our hypotenuse in our first one, which is 25. So 25 squared is equal to a squared plus 9 squared, because we still have the a and we have the 9. Now, rearranging this by taking away 9 squared from both sides results in that 25 squared is minus 9 squared is equal to a squared, and we can rewrite this as a squared is equal to 25 squared minus 9 squared. That means a is equal to the square root of this particular expression. And we just put that into our calculator. So we just do the square root of 25 squared minus 9 squared. Hit execute, and what we get is 4 root 34, which we'll deal with in a later lesson, but that's approximately equal to 23.3238. Now, to two decimal places, this is just going to be 23.32. 23.32. Right, and if we look at B, we have the same idea. Our hypotenuse is 20, so 20 squared is equal to a squared plus 7 squared, and we can rewrite this as a squared is equal to our hypotenuse, take away our given side squared. That means a will be equal to the square root of 20 squared minus 7 squared, and we can put that straight into our calculator. 20 squared minus 7 squared. Alright, the end result is 18.734994. Right, and this is approximately equal to this. We do the two squiggly lines. Now, if we're going to round this to two decimal places, all we need to do is find our second decimal place, which is 3, and then we look at our critical digit, which is this one right next to whatever place we're interested in. If it's greater or equal to 5, then we round up. Because it's not, when we drop everything here, and our answer is a is equal to 18.73, or a is approximately equal to 18.73, and you can also write two decimal places if you would like. Alright, looking at C, we have our hypotenuse, which is 30. So 30 squared is equal to a squared plus 11 squared, which means a squared is equal to 30 squared minus 11 squared, and a is equal to the square root of this. So a will be equal to 30 squared minus 11 squared. The square root of 30 squared minus 11 squared. Hit execute, and we get 27.9105. 27.9105. And if we were going to round this to two decimal places, we would find our second decimal place, which is here, and we look at our critical digit, which is the 0 here. Because it's not 5 or greater, that means we drop everything after the 1, and a becomes approximately equal to 71.91. And we can write to two decimal places. Alright, for D, our hypotenuse is 40. So 40 squared is equal to a squared plus 13 squared. That means that if we rearrange this, a squared will be equal to 40 squared minus 13 squared, and a will be equal to the square root of this. So a is equal to, or more realistically, a is approximately equal to, and let's solve. The square root of 40 squared minus 13 squared. Hit execute, and we get 37.8285. Now if we're rounding this to 2 decimal places, we're going to find our second decimal place, which is the second one after the decimal place, and we're going to look at our critical digit here, which is 8. Because it's greater than 5, we need to round up, which means we increase the 2 by 1, and our answer A is approximately equal to 37.83, and we can write to 2 decimal places afterwards. Alright, that's it for this video. Hope it was helpful, and I will see you in the next one.